So Pierre, I will be happy to, the floor is yours. It's a pleasure to have you with us. אחרי שפייר בעצם יציג, אני אנסה לתמצת את מה שהוא אמר וננסה לענות לשאלות. So Pierre, please.
Thank you very much, Oren, and thank you to Electreon for inviting me. So yes, I'm Pierre Delega. I'm in charge of autonomous and electric mobility project within Vinci. And sorry, my Hebrew is a bit rusty, so I'll be speaking in English today. Vinci is a big corporation. Vinci is a worldwide corporation. We are present in more than 100 countries. To give you a number, an idea of the size of Vinci, we make 72 billion euro annual revenue. We are 280,000 employees worldwide, and we involved in construction, energy, and concession businesses. Within France, we have different types of concession. What you see on that slide is the highway concession. We are the biggest highway operator in France. What does that mean, highway operator? It means toll highway operator. In France, most of the toll, 80% of the toll network, of the highway network, sorry, is operated through tolls. And we are the biggest highway operator. We operate about half of the highway network in France, so about 4,500 kilometers. The next slide, please. Then obviously we need to facilitate the deployment of electric mobility. We see that in Europe, all the OEMs, all the car and truck manufacturers are being forced by the European Commission to decarbonize their vehicle, and that's understandable. We all face the same climate urgency, and we on the infrastructure side, we have to facilitate, to foster that transition of the vehicles to electric mobility. And this is being done right now with electric vehicle, battery electric vehicle. What do we do specifically on the infrastructure side? Along a highway, we deploy chargers, high power chargers. Not too fast, please. Just one. Thank you. We have to give you an idea of what we have deployed so far in France along the entire highway network. We have just under 4,000 high power chargers right now, and we need to multiply this by 8 in the next 10 years. This is for passenger vehicle. For trucks, we need to do the same thing, but we have barely started. For trucks, we have just a few charging stations right now, and we need to have 12,000 by 2035, so in 10 years. So we are really deploying these static charging infrastructures as we speak. And the main two challenges for us is the first one is real estate. If you go back one, that's one constraint that we that is often under discussed and overlooked by most, but for us is the biggest one. We will not, to put it simply, we will not have enough space to deploy all these static chargers. Static chargers take way more space than fuel pumps because they deliver less kilometers or miles of range in more space. So we need way more parking areas in front of all of these chargers than we had for fuel pumps. Also for trucks, we need to reorganize our truck parking areas along our highway so that the truck have drive-through, charge-through parkings. We don't want electric trucks to charge to park along the curbs like they do today because of the fear of the trucks hitting the chargers. So the requirement for real estate is going to be massive, and we already know that we don't have that space. The second challenge for us is electrical. When you have big static chargers along the highway, you need to bring all that power at one specific area. And that can, for the biggest highway service area, represent several dozens of megawatt. That's a lot of power in one specific location. So for our biggest highway rest area, we will need as much power as international airports in one highway service area. So this is also tricky, and it needs to be anticipated way in advance. This is possible, but costly and need to be anticipated way in advance. The real estate constraint is even more stringent. When you don't have the space, you don't have the space. You cannot make it up. So these are the two main challenges that we face today when we deploy static chargers. The next slide. Um, so we obviously believe in electric vehicle and battery electric vehicle, but what we observe for the vehicles which will have the biggest batteries is that doesn't seem to be very optimal, very efficient approach. Big batteries have many downsides. Basically, all the inconvenience of electric vehicles are from the battery. A big battery has limited range. There's not as much energy in one unit of electric battery, whether you take a kilogram or a liter, whatever, as you have in a kilogram or a liter of diesel or gasoline. It's impossible. A liter or kilogram of gasoline is 40 times more dense in energy than the same volume or mass in lithium ion battery. So even if we have many improvements in batteries, which we will have, obviously, and there will never be as much energy, intrinsic energy in batteries than in oil, gasoline, and diesel. Big batteries require stopping time to charge. That's a big downside for logistic companies because they want to do the exact opposite. They usually want to have their fleet drive as often and as much as possible. Downtime is against their business model. Another inconvenience of big batteries is a payload. Big batteries are very heavy, so logistic company end up carrying batteries, more batteries, and less payload. And obviously, they're not being paid for carrying battery, only payload. So this is also against the core of their business model. And electric for the vehicles that will have the biggest battery, the trucks, the electric trucks, they're also way more expensive today than a diesel truck. So right now in France, we have about 2,000 electric trucks out of 600,000 trucks. And these first trucks are about 3 times the price to purchase as a diesel truck. So of course the TCO, the total cost of ownership, comes down afterwards because electricity can be cheaper if you charge overnight at your depot. But the acquisition cost is still a big hurdle because many logistic companies are just small companies that don't have the cash to buy all these heavy vehicles. So these are like operational downsides of having big batteries in vehicles. And there are also obviously environmental downsides. Let's not forget that we're all doing electric vehicle to decarbonize. That's the ultimate goal. But if you have big batteries that are being produced in country where the national energy mix is very carbonated, like China, and right now, the vast majority of the batteries for trucks are produced in China and also for passenger vehicles. Then these vehicles have a very high carbon footprint due to due to their production. So of course, there's zero emission during the mobility phase, but they emitted a lot of carbon beforehand during the production. So this doesn't seem very optimal. So in France, that's the next slide. uh, the our Ministry of Transportation, our DOT, if you would, has reviewed in 2021 different solutions to decarbonize the truck. So they have gathered in France about 100 different experts. There were car and truck companies, energy companies, highway operator, researcher, different types of stakeholders, all the stakeholders required for electric mobility. And these experts analyzed and benchmarked the different technological solution to decarbonize trucks. So big batteries is possible, but it has all the downsides that I just mentioned. Hydrogen uh, was in Europe kind of a magic solution a few years ago. But hydrogen has many limitations. First of all, it needs to be green hydrogen, not gray hydrogen. Otherwise, you don't really decarbonize. And in Europe, at least, the green hydrogen would be required by other industries that use hydrogen for their processes, and that need to switch to green hydrogen. So these are the cement industry, steel industry, fertilizer industry, and of course down the road the aviation. So there will be a limited quantity of green hydrogen for mobility. So green hydrogen is only going to be a limited part of the mix for trucks. Then we have biogas and biodiesel. These solutions are viable, they're technically feasible, they already exist today, but in France, we will not have enough biomass for these solutions to be the mainstream solution. So we should basically continue to use them, but there would be also a limited proportion of the entire mix because of the limitation in the quantity of biomass that we can generate upstream. So the Ministry of Transport in these studies, which are public and available in English also, has concluded that the best solution to decarbonize trucks is electric road system. So fewer batteries on board the vehicles, but the ability to charge as you drive. This is all computation done. This is by far the most efficient way to decarbonize the trucks. So the French government has proposed what you see bottom right of this slide, a big deployment plan for ERS in France. They propose to cover the entire France territory with 9,000 kilometers of highway, of ERS on highways by 2035. So that's 75% of the France highway network in 10 years. So that's very ambitious, and it would cover the entire France. Before doing that, they asked private players like ourselves to test and compare the different technologies to select the best one to deploy at large scale. That's the next slide. And so, and as this is what we're doing right now in our project, in our Charge as You Drive project, that I will give you a few details just in a second. And this is just before that a summary of the type of win-win-win-win situation that we believe ERS could be. In our view, ERS, from an environmental point of view, reduces the carbon footprint of the batteries by making them smaller and hence of the vehicles. Also, less material needs, so we don't have to extract from the ground lithium, nickel, cobalt, manganese, iron, phosphate, all these materials that are precious. Also, for us highway operator, reduced land artificialization, less real estate needed to electrify, and that's very important. I think strategic. If you look at the transporter logistic company point of view, for them it's win all along. You have unlimited range. You don't, as long as you are on the highway that is equipped with an ER system, there's no range limitation. You don't have to stop to charge. You have bigger payload because lighter batteries, and the vehicle costs less. So for you, it's a no-brainer. From a OEM point of view, the main benefit is that this approach is compatible with the current approach. Right now, all the OEMs are going for vehicles with battery electric vehicles, and ERS is a battery electric vehicle. It is fully compatible with static charger. It's just that the battery is smaller. So for the OEMs, they don't need to make a big industrial decision between hydrogen or biogas or battery. Is the same as there's 100% compatibility of an ERS vehicle with the current static chargers that we're deploying. So that's a very key. And also, if you sell your vehicle cheaper, then you can probably generate more margins, because right now the electric vehicles, especially for trucks, are so expensive that the OEMs don't make much margins on them. Uh, Another very important benefit, type of benefit, not from a private player like us, but for the public administration, is the reduced need to import batteries. Some countries like Asia have way too advanced on battery. They have 15 to 20 years lead time on batteries, and we will not. It would be very difficult for us to catch up. So ERS is a way to reduce our battery needs and create more job and invest in our national infrastructures in France. So that's very strategic and good for our trade balance. Next slide. Yeah, so you all familiar with the different solution family of technology for ERS, catenaries, conductive rail, induction. That's just to say that within Vinci, we don't study catenary. We don't like it. We don't believe it's viable for different reasons: maintenance, safety on the highway, and also only compatible with big trucks. So it's not really a solution that we can imagine. For us, we want to only study the technologies that are compatible with all types of vehicles. Obviously, the main target of ERS for us is the vehicle with the biggest batteries, so the trucks. But if you install an ERS solution along the highway, it needs to be compatible with all the vehicles. Why? Because the big batteries, the biggest batteries would be on the trucks, but the biggest volume, accumulated volume of battery will be on passenger vehicles. So if you do a solution that doesn't work for passenger vehicle, you miss the target. So right now in all of our project, we only study induction mainly, as you will see in the next slide, and we also study conduction in one project. So next slide. Next slide is a quick overview of the portfolio of projects that we have on ERS within Vinci. So these are Vinci is involved either through Vinci Highways or Vinci Construction or Vinci Energy. We have many different business units worldwide, and we have about 10 different projects on ERS in Germany, France, Sweden, and Canada. As you can see on this slide, you see a lot of Electreon logos. You see Electreon everywhere, basically. Um, we are, we have a strong preference for induction. For us, induction is the most elegant and most practical solution. That's why we study and we work on induction in all of our project. In the project that I'm more closely responsible for charge as you drive, we also study another solution, a rail solution, conductive rail, from a company called Ellen Road. So if we look at this project more specifically, we study this type of technology. And what's very new about this project is that it is on the highway. Most of the other ERS projects in the world focus on other use cases, other road environments. So either city or urban um, or peri-urban, like we say in Europe. But highway is a different game. Highway is way more demanding technically, because on the highway you have to go faster. You have Therefore you have to charge at much higher powers, and because on the highway you have way more traffic. So uh, this traffic is creates a lot of mechanical constraints on the systems that you put in the road. So that's why we say that our project is a world first, because it's the first time it's been done on a proper highway. So we have induction and conduction. Next slide, we see that in induction, this Electreon system is way more advanced. We have already tested everything before installing on the highway. We did tests in different labs, in different test tracks, and now we have installed on the highway, on the 18 highway. The other solution, the conductive rail solution, is still being tested. It's been delayed for technical reasons, and then it's still being tested in closed test tracks, so not yet on the highway. So yeah, so now on what we did on our highway in France, This is a picture taken recently of the truck driving on the highway. And what we did on the A10, A10 is a pretty big highway. It's not the, some rural highway far deep in France. No, no, it's one of the main highway leaving Paris and going to Normandy and to Bordeaux, southwest of Paris. Is really a big highway with lots of traffic. So we did different construction phases last winter. Here you see what we had to do for connected to connect to the grid. So we had to do some trenches and connect to the medium voltage public grid, which was available close by. Then next slide, you will see pictures of what we did on the highway. So on the highway, we had to connect uh, one power station that was connected to the public grid to the different management units of Electreon. The management units, as you may know, they power the coils. So we had to do trenches and holes along the highway, on the ditch of the highway, to bury the different management units because we wanted everything to be buried. We didn't want to have everything above ground. So that's what we did. And then we pulled the cable from the power station to the management unit, and then from the management unit to the coils. So this is what we did. This is mostly Vinci expertise. Most of these tasks were not new for us. This is the standard business as usual expertise of Vinci entities, whether Vinci Energy or Vinci Construction. So for us, I think we were hopefully good partners to Electreon on this. We managed it on time anyway. What was new for us is what you see on the right side here, coil installation. We never did this on the highway, but we managed to do it on time, and we achieve pretty good pace of installation. So that's a good result. Next slide. And since the installation was done in April, we've been doing test drives. So we have 4 vehicles that we're testing on the section, that we have been testing on the section: a truck, a passenger vehicle, a bus, and what you don't see on that picture, a light duty vehicle. So the first result, which is very good result, is that it works for every type of vehicle. And there's no question of interoperability. Any type of vehicle you put, it works. So that's a very good achievement. And then we have done over the last couple months different measures by independent expert labs that came on the highway that did on-site measures on energy transfer, on electromagnetic fields, and thermal also measures. And the results will be published soon. These different labs are still drafting their final report, but they already said and confirmed that the results are very good. So for energy, I can give you a couple of figures on energy. They confirm that we can uh, charge at peaks above 300 kilowatt and average above 200 kilowatt. That's for the truck, for the vehicle that is drawing the most power. So that's an amazing result. It's actually beyond our expectation. Um, for the electromagnetic fields, we had one independent lab measuring all the different fields, EMC, EMF, comparing this to the regulation threshold. And all the fields are below the regulation thresholds, and actually with good margin. It's quite comfortable compared to the threshold. So this is also very good news. And on the thermal measures, there was no question. There was a very marginal heating of the coil, but that has nothing to do compared to the difference of temperatures that the road itself can go through between winter and summer. So there's no possible degradation of the road from coil heating. So that was also a very good news. So this is what we did, and we also made sure, and this is what you see on the right side here, that we could uh, perform with no problem our regular road maintenance activities that we do about every 10 years on the highway. About every 10 years we renew the wearing course, the top layer of the highway. So we did that on the section that had the Electron coils underneath, and we we could easily confirm that there was no problem. And the coils are deeper, so we don't touch the coil, we don't damage the system. This was quite easy actually. So that's where we are right now. It's we're very happy. I think we have maybe one more slide. Uh, yeah, this is the feedback from the independent labs, which states what I just said about the absence of heating, the regulation threshold of on electromagnetic fields that are um, being respected, and that the power is was one of the main indicator for us. The main research question, the main question we wanted to address in this project was is induction capable of transferring powers that are high enough to power an electric truck on the highway, so several hundreds of kilowatt? And the answer is clearly yes. So that's a very good achievement. So that's where we are right now. And this is, I think, a quick video of a test drive we did recently. Or is it just an
Just a
image maybe?
picture, it's not a
Just a
video.
picture.
Yeah,
It's just a
just
picture. So this is our section, 1.5 kilometer long. We have the truck right now that drives on the highway. It can go up to legal speed limit, which is in France 90 kph. Actually, speed has no impact on the power transfer. This is also very good news. And we see on a very regular basis powers above 200 kilowatt being transmitted. So it just works. It works. It's very seamless for the user. It works in full traffic. We don't have a reserved or protected lane. This is the full traffic of Highway A10. Um, so this is where we are right now, and we're waiting for the final reports from the different labs. But it's looking very good right now. That's all I think I wanted to present on this project. I don't know if you have
yeah.
question. Have
If you can give a brief about the business model, how do you see ERS at a large scale in France? Who
yeah.
pays to whom? Yeah.
Yeah, definitely. In France, the toll highway model, the highway concession model, uh, is a good model to finance big investment like ERS at scale. Basically, the way it works is that any new big investment is financed by the toll. The only business model of a toll highway is the toll. That's the only revenue we collect. So the toll pays for all new capex, all new investment, whether it is a new highway, whether it is a new lane on an existing highway, or tomorrow ERS. So we have already determined that ERS is definitely financeable. It can be financed through toll. Um, Actually, that's not too difficult. ERS is a fraction of the cost of a new highway. A new highway like the A10 is almost 20 million euro per kilometer, and we have financed these highways through the toll over the last 25 years. So installing something like ERS that is a fraction of this can be easily financed through the toll. So toll highway concession contracts are a good mechanism to finance investment like ERS over the long term. That's number one. And so what we envision right now, after our first kilometer and a half of a test section, and before the big plan in France of having 9,000 kilometers of network deployed, that would require a big decision from the French government, is to deploy first corridors. So we could have corridors of 50 kilometer, 100 kilometer, 200 kilometer that could be deployed in the near future. Uh, while waiting for the big decision of the French government to deploy the 9,000 kilometer network. And one of the one we want to study first is on A10 also. It is Orleans to Paris. Orleans to Paris is 100 kilometer, uh, and there are many trucks leaving Orleans every day and delivering goods to Paris. Orleans is a big base for logistic company to deliver to Paris. And so we are talking right now to the different logistic companies of Orleans to determine to confirm the interest and to see how much of this section we need to be installed to fit their use case, their commute use case every day to Paris. And this typically, this new step could be financed through an amendment to the current concession contract. This is what we do on a regular basis. Every time we have uh, a new investment to do, that is, for example, another lane on the highway, we ask the French government for an amendment of the current concession contract so that they let us finance this new investment through the tolls. So this is our next step. Could happen hopefully soon, before 2030, and that's a natural follow-up to this first section of 1.5 kilometer.
Great. Maybe last question, if you can explain a little bit more about the interest that you see from other, let's say, region, countries that are coming to France to hear about this.
Yes, we since our section is operational, and even before that, when we were installing it during the construction phase, we have lots of interests from many delegations in the world. We have hosted 8 delegations from Japan, so OEMs, different OEMs. I don't think I should name them, but the different car OEMs, Japanese car OEMs, and tier ones, ministries, Japanese ministries. 2 types of Japanese ministries have come. Big cities, major cities in Japan also have come to see the project and are highly interested. We had a Chinese delegation also from a big city in the all the cities in China are big, but this one is a big one in the center of China, which came 2 weeks ago. We have a US delegation coming soon in November. We have many OEMs, European OEMs, passenger vehicles, and soon trucks, logistic companies, highway operators that came from Italy, Spain, Germany. Yes, we have, I would say, global interest from all the stakeholders of EIS, which are the OEMs, all types of OEMs, tier ones, ministries, transport ministries from different countries, uh, highway operator and road operator, research labs. So I think there's a growing landscape on ERS in general, and I would say on induction specifically, because most of these people work or are interested in induction. We don't see many stakeholders on the other 2 technologies, and that's good. We're happy to be the first highway section, but we don't want to be the only one, so that's very good.
Um, Thank you, Pierre. It was a pleasure to have you with us here, not just to thank you about this presentation, but for 7 years that we're actually building a good collaboration between the two companies, and not just in France, as you just explained. So thank you for the time. Um, I will maybe go to Hebrew. So thank you, Pierre.
Okay.
Thank
Thank
you,
you, Aaron, for
everyone.
the opportunity.
Thank you.
Thank you.
Thank you very
Thank
much.
you all. Bye bye.
So